Hey, so in the last video, we defined expected value as the average value we expect a random variable to take on in the long run. We played this game where the object was to hit the crossbar of the goal. I determined that the probability that I hit the crossbar is about 20%. And so my expected value is that I expect to hit the crossbar 0.2 times per attempt. But what if we raise the stakes a bit and put money on the results? Let's say every time I hit the crossbar, I win $5, but every time I miss the crossbar, I lose $1. So the random variable that I'm interested in this game now is the money that I earn, or lose. Let's say I play the game 10 times. What would I expect to win or lose over those 10 attempts? Well, assuming the probability is still 20% or one crossbar every 5 attempts, let's observe what we might expect to happen. That's right, I expect to win $2 over 10 attempts. $2 divided by 10 is just 20 cents, so I could say that on average I expect to win 20 cents per attempt. That's my expected value per attempt. It turns out there's a formula for calculating expected value for situations like these. You take the value of each event and multiply it by the probability of that event, and then sum those up. In the case of this game, there are two possible events. I either lose $1 with probability 0.8, or I win $5 with probability 0.2. So I plug in each of these events into the equation with their associated probabilities, and what it tells me is that on each attempt, I would expect to lose 80 cents, but I would expect to win $1, and those even out to 20 cents per attempt. Finally, I want to stress again that expected value is the average value we expect in the long run. So I'm not going to get $2 every time I play the game 10 times. But over many, many attempts, in the long run, as long as my probability stays 20%, I can expect on average to win 20 cents per attempt. In the next video, we'll compare this game's expected value to the expected value for a game that has a different, lower probability of success.